A local county has an unemployment rate of 6.4%. A random sample of 20 employable people are picked at random from the county and are asked if they are employed. The distribution is a binomial. Round answers to 4 decimal places. Well, knowing that we have a binomial distribution helps us out and gives us a hint as to how we will find the probabilities that we're required to find here. So first we want to find the probability that exactly 3 in the sample are unemployed. Since we're using a binomial distribution, the functions that the calculator has available to us are binom CDF and binom PDF. Whenever we want to find exactly a certain number of items out of a group, find a probability that way, binom PDF is the function that we will use. So binom PDF takes 3 inputs. Its inputs are n, p, and x. And we separate those by commas. N is the number of trials in the experiment. So we have 20 employable people. So the number of trials is 20. P is the probability of success. And so our success here is choosing a person that is unemployed. So that would be 0.064, which is 6.4% as a decimal. And x. X is the number that we would like to observe out of our sample. So x in this case will be 3 because we want exactly 3. So binom PDF, we get the calculator out and press second vars, which takes us into the distributions menu. Then scroll down until we get to binom PDF. There's 2 items there for binomials. Just make sure you get the correct one. The number of trials is 20. We put that in first and then comma, 0.064, comma, 3. And it will calculate our probability for us, which in this case is 0.0971. I'll use 4 decimals because that's what it says in the problem. Find the probability that there are fewer than 2 in the sample that are unemployed. So if I want to get fewer than 2 would be either 0 or 1. So 0 up to 1 is what I'll say. And I could do binom PDF twice and let x be 0 the first time and then x be 1 the second time and add those together. That would work just fine. However, binom CDF, a cumulative distribution function, adds together probabilities for me. So binom CDF, what it does is takes 3 inputs, again, n, p, and x, and the number of trials is still 20, probability of success is still 0.64, but x, if I give the value that I want the counting to stop with, so it would start with x equals 0, feed that into binom PDF and get that probability. Then it would take x equals 1, feed that into binom PDF, and add that with the total that it has so far. So this will do exactly what I want in one statement. So that's very nice. Let's use it, and we find it in the same place, second vars. But scroll past binom CDF, scroll past binom PDF to find binom CDF. So 20 is the first input, comma, 0.064 is the second, and 1 is the last. So 0.6307. Find the probability that there are more than 2 in the sample that are unemployed. More than 2. So that is a similar situation, but instead of being fewer than 2, which would be 0 up to 1, more than 2 is going to be from 3 to the sample size, which is 20. Now, binomial CDF can still be helpful. It's just that it always does its counting up to what your last input is. So in this case, I could do binomial CDF 20.6064 and give 2 as the last input. So what that will do is it will add together the probabilities from 0, x equals 0, x equals 1, and x equals 2. And if I subtract that from 1 and form a complement, then that would give me the sum from 3 to 20 instead. So if you look at this histogram, it illustrates what I'm talking about. So what I want to do is I want to find the probability from 3 to 20. So I have, in this situation, shaded the bars representing the binomial PDF probabilities. That's what each of these bars represent. But I've shaded the bars from x equals 3 all the way to 20. Notice a lot of these bars are close to 0, and that's okay. That happens with binomials. But these are the shaded ones. That's what I want to find the probability, the sum of. So what I'm doing is, instead of getting that value directly, I'm taking the sum of the first 3 bars, 0, 1, and 2, which I can get from the binomial CDF function. You see, it does a running total of binomial probabilities. So the first binomial probability is the same as the first binomial CDF probability. The second, if I take 0.2664 and add it to 0.3643, that would give me this value right here. So these are the sums of all the previous binomial PDF values. So if I get the sum up to 2, which would be 0.8673, and take its complement would be 0.1327, which is what I'm looking for. That's the shaded region in blue. On the calculator, what I have to do is just simply put in 1 minus, go to second distributions, and scroll down to the binomial CDF function, and give 20.064 and 2 as my inputs. So 0.1327, just like we determined in the other app. Find the probability that there are at most 2 in the sample that are unemployed. So at most 2 would be 0 up to 2, but also including 2. So just slightly larger than what we had in part B. But since it's starting from 0, we can do binomial CDF directly. So 20 is the number of trials. Probability of success is unchanged, but we want to go up to and including 2. So that's going to be, come down to binomial CDF 20.064 and 2 is my last input. So 0.8673. And notice that is complementary to the previous answer that we have, because more than 2 and at most 2, these are complementary ideas to one another. So you can either have more than 2 of something, which would be 3 or greater, or at most 2 of something, which would be 0, 1, or 2.